We're back for another video where we're going to find the center, foci, and vertices of the ellipse. Last time, all of our problems were centered at 0, 0. This time, they won't be. So our first one is already set up for us to find the center at 2, -1. I just read this based off of what x value can I stick into the parentheses to make that set of parentheses 0. It would need to be 2, so the 2 minus 2 would be 0. And I would need y is -1 to get -1 plus 1 to be equal to 0. That's going to be my center. Now our a is going to be the square root of 16 is going to be 4. And our b is going to be the square root of 9 is going to be 3. Because the 16 is the bigger number and is with the x part, this is going to be a horizontal major axis. So the major axis is parallel to the x-axis is what I'm saying. Parallel to the x-axis. So we're going to go 4 to the right to get to a vertex, and 4 to the left to get to a vertex. So I have a vertex at -2, -1, and I have another vertex at +6, -1. I have additional points that are on my minor axis of, and I'm just calling them P1 and P2 for point 1 and point 2, that are going to be at 2, -4, and 2, 2. And I'm going to now find my foci by saying that C is the square root of b squared of a squared minus b squared. So focus 1 is going to be 2 minus √7, -1, and focus 2 is going to be 2 plus √7, -1. It did not ask me to draw any picture for this, so I won't do that. That'll be another objective here that we'll do some graphing later, but we were just to identify the center, which we did, the vertices, which we did, and the foci, which we did, and I also gave you these additional points which will help you with graphing, even though we weren't asked for them. Now let's start with 36, x minus 3 squared, 9 times y plus 3 squared equals 324. So we're going to divide everything by 324. Nine goes into 32 3 times with 5 left over. 9 goes into 54 6 times. So just as I suspected, many times they take this 36 and this 9 to multiply them to get this number. That's not always the case. So our A is 6 and our B is 3, and this is going to be major axis parallel to the y-axis, meaning that this looks vertical, it's stretched vertically. My center is at 3, -3. My vertices are at 3, -9, and 3, 3. We're adding 6 and subtracting 6 from the y coordinate here since we're stretched out vertically. I have additional points, P1 and P2, that are going to be 0, -3, and 6, -3. And my focus is going to be square root of 36 minus 9 is square root of 27 is going to be 3√3. So focus 1 is going to be 3, -3 minus 3√3. Focus 2 is going to be 3, -3 plus 3√3. Lots of 3's in this problem. Now we're going to have 3x squared plus 5y squared minus 18x plus 70y plus 257 is equal to 0. Let's get our x components together. Let's get our y components together. And let's get our constant over to the other side of the equation so that this is set up for us. We're going to factor out our greatest common factor of, well, our leading coefficient, even if it's not the greatest common factor, because we want that x squared to have a coefficient of 1. Similarly, we want y squared to have a coefficient of 1, so we're going to factor out that 5. I haven't left myself a lot of space here to write what my numbers are going to be to go on the right-hand side, so I'm going to zoom out a little bit. Half of -6 is -3, and -3 squared is 9. I added 3 times 9 is 27. So I'm going to add that on the right. Half of 14 is 7. 7 squared is 49. And if I multiply by 5, that's 245. Let's just do a little scratch work here. 245 plus 27 is 272. We're going to subtract 257 from that, and we're going to get 15. Let's just make sure that that's right. It would make more sense if, yes, it's going to be 15. That's right. So 15. And this is going to be 3 times x minus 3 squared plus 5 times y plus 7 squared is equal to 15. So we're going to divide through by 15 and get x minus 3 squared over 5 plus y plus 7 squared over 3 is equal to 1. Notice that neither 5 nor 3 are perfect squares here, so we're going to get our a and our b that are going to be square roots, and that's okay. So my center here is going to be at 3, -7. My ellipse is going to have a major axis parallel to the x-axis, since the a squared equals 5 is bigger and it's with the x piece. So I'm going to move horizontally to get to my vertices. And I'm going to move in the square root of 5 direction. So 3 minus root 5, keep the -7. 3 plus root 5, keep the -7. Additional points are at 3, -7 plus I'll do minus first. Minus root 3, 3, negative 7, plus root 3. And my foci, I'm going to solve here that c is going to be the square root of 5 minus 3. C is going to be root 2. So F1 is going to be 3 minus root 2, negative 7. And F2 is going to be 3 plus root 2, negative 7. Now for one more problem here. 36x squared plus y squared minus 288x plus 540 equals 0. Let's get my x parts together. And let's get my y parts together. And let's get my constant over to the other side. So 36x squared minus 288 divided by 36. So 144 divided by 18. 9 goes into there 72 times. Goes into there 8 times. All right, so that's 8. Yeah, that makes sense. Plus, and we know this is a y minus 0 squared. Half of negative 8 is negative 4. Negative 4 squared is 16. 16 times 36 is going to be 576. 36 times x minus 4 squared plus y minus 0 squared is equal to 36. So x minus 4 squared over 1 squared plus y minus 0 squared over 36, which is 6 squared. I don't need to write the squared there, but that's over 1, is equal to 1. 1 is 1 squared, so b is 1, a is 6. This is going to be parallel to the y-axis for the major axis. And our center is at 4, 0. My vertices are at 4, negative 6, and 4, 6. My additional points are at 3, 0, and 5, 0. And my foci are at, c squared is 35. C is root 36 minus 1 to root 35. So we've got, this is vertical, negative root 35, keep the 4. Positive root 35, keep the 4. And there we go. That just shows you, like I was saying in the first video, that not everything is centered at 0, 0. Sometimes we're going to have to complete the square, and things are going to get a little more interesting. Hopefully you see now why completing the square was such an important technique to learn in pre-calculus part 1. And we're going to continue to use that technique here throughout our sections where we talk about conics. So we've used it to talk about circles in pre-calculus part 1, and we've used it in pre-calculus part 1 to talk about parabolas. We just used it again to talk about parabolas in this section that were vertical and horizontal. Now we've used it to talk about ellipses, and we'll have some other shapes that we're going to talk about in later sections where we'll also use completing the square. And that won't be the end of using completing the square in math either. So we will continue to use this tool that's in our toolbox for several different applications. All right, I'm going to come back and we're going to go the other way now, and we're going to be given the center and the vertex and the focus and the additional points, things like that. We'll be given enough information. We'll generate the equation in our next videos.